For more videos like this for Discrete 1, you can take a look at Sarai Studies, link is in the description box below.
We're told to show or prove that this compound proposition is equivalent to this compound proposition. Again, you want to identify what is the longest or most complicated looking side. That's this one. So I'm going to start off with that. And then the goal is to realize I need to get this side to look like this side using this table. So I'm going to say, okay, what is this equivalent to? Well, I see a negation symbol and parentheses separated by an or. I'm going to distribute this negation to this p. So that becomes not p. Negation really means opposite. So you're taking the opposite of p will be literally the opposite of p. The opposite of this or symbol will be the opposite, which is and then the opposite of this whole thing is going to be the opposite of the whole thing. So what law did we use? That's De Morgan's. When you have a negation outside, but in this case we have an or and then something else, that's Q in this case, it's going to give you all that. So you can go through that, or you can just kind of understand you're just distributing and taking the opposite of everything. But the problem is this still does not look like this. So what do? We keep going. What is this equivalent to? Well, I see another negation. I can do the exact same thing. So I'm going to drop this stuff down, not P and, then I'm going to distribute the not here. So it's going to be not P, and then the opposite of and is or, and then the opposite of Q is literally the opposite of Q. So again, we use De Morgan's. This still does not look like this, so we keep going. What is this equivalent to? Well, I see something really easy to identify. Double negations. So think math. Negative times a negative makes a positive. So these cancel out and you're just left with what it was in the beginning, which was P, and then you just bring everything else down. And what law was this? This is called the double negation law. So that's when you have two nots. When you're taking the opposite of something, you're just left with that something. But this still does not look like this. So we keep going. We say, what is this equivalent to? Well, you try to identify what's the template here. You have something and something. And here I see something and something is going to be equal to all that. And you can go through that, or you can just follow the way I think about this. Anytime you have something and something or something or something, when that something comes first and not at the end, you're going to have two parentheses. The thing that you saw first is going to go first in each of the parentheses. So not P, not P. The sign that's on the outside is going to go on the inside now. So these signs position switch. And so the sign that was on the inside is now going to go on the outside. And then you only have two things left to place, and you're just going to place them in the order that you see them. So P is going to come here and not Q is going to be here. So again, first thing goes first. The sign on the outside goes on the inside. The sign on the inside goes on the outside now. And then whatever you see first goes in your first empty spot, and whatever you see second, it goes in your second empty spot. But there's a problem. This still does not look like this. So what do? You keep going. But then you ask yourself, well, what can I do now? Well, look, here I see something and it's opposite. And these are connected with an and operator. And we know that an and operator only outputs true if this and this are true, meaning they both have to be true at the same time. But if we have something here and this will always be the opposite of that something, then they will never be true at the same time. They will never be the same value. They'll be opposites of each other. So because of that, we can never get true for this entire thing. So this is just always going to end up being false. And what law is that? That's the negation law. So when you have something and the opposite of that something and the opposite of that something, it's always going to give you false. So this just becomes false, and then we can drop everything else down, not P and not Q. Again, we use the negation law, so let's say that. I forgot to write this one. So this is the distributive law. So we have something and something and something. That's the distributive law. Now still, this does not look like this. So we keep going. What is this equivalent to? Well, we have false or something. Here we have false or something. That's exactly what we have over here. So what is it saying it's equivalent to? It's saying it's equivalent to that something. So in other words, when you have false or something, you could just get rid of it. It's going to be that something. So false or something, get rid of all of this stuff. It's just going to be that something. So we're going to have this be equivalent to not P and not Q. So this is the identity law. And then notice, we finally have this looking like the other side. So we managed to go from this side all the way to this side by using known equivalences. We proved that these are equivalent. And so we are done, and we write our little box, and that's it for this video. I'll see you in the next.